Hey guys, this is going to be a video to get you through the notes, which is your homework for the weekend. 3.8, which is solving rational equations. So basically we're just going to be taking everything that we've been doing with rational expressions, we've been simplifying them, and now there's an equation involved, which just means there's an equal sign. So the first thing that I want you to do is go to the bottom of your paper, and this says 45, it should say 46, because your quiz was 45, so make sure you correct that. And let's get through these three examples in the notes video, and then on Monday we'll practice in class. All right, so you're going to be able to solve equations involving rational expressions. This first example, A, is not too complicated, but just like if we were to try to put these two things together, even if we didn't have any of this over here, if we were just focusing on this, we would not be able to combine these unless they had a common denominator, right? So even though there's an equation, we still want a common denominator if we're going to be working across this equal sign. And you're going to see why in just a minute. So let me rewrite this down here. All right. What we're going to do is we're going to find the common denominator, and we're going to multiply every single term by it. So I've got to figure out, I've got an x, I've got a 3, I've got a 3x. What could be my common denominator? Well, to me, it seems pretty obvious that if I just multiplied this by 3 and this by x, then I'd have 3x. So that works. So I'll just multiply each term here by 3x times 3x, this times 3x, and this times 3x. So one of the questions you might be asking is, how come I don't have to write it as 3x over 3x, right? Why don't I need to use a 1? Well, now that we have an equation, it's just like any other equation where all we really need to do is make sure that whatever we do to one side of the equation, we do to the other side. So I could multiply this by 3 if I wanted to, or 4 or 92, as long as I multiply everything over here by that same thing. So I'm still maintaining equality by doing that. I've just made sure that I multiplied every single thing by the 3x. And when I do that, something interesting is going to happen. These 3x's are really just 3x over 1s. So once I've multiplied by 3x, you'll notice there's some stuff that's going to cancel before I even have to go multiplying anything. So I'm going to be left with, in this first term, that's just 3 times 1 now. This second term is just a minus 1x. And this third term is a negative 1, because everything else canceled. And now that I have an equation like this, all I'm worried about is getting x to be by itself. So I would just subtract 3, negative x equals negative 4, and then divide by negative 1, x equals 4. And that's that. All right, so the key here, multiply every term by a common denominator. And I say a common denominator. It doesn't necessarily have to be the least common denominator. It's convenient if it is, but you could multiply this by 6x or 9x squared. That would be a common denominator. But in the end, you'd have to reduce. So it doesn't necessarily matter if you choose the least common denominator or not. All right, example B. We got to find a common denominator here. So we've got an x minus 4, and we've got a 3. One real easy way to find a common denominator is just to multiply all your denominators. So if I multiplied these two, I would get 3x minus 12. And I can guarantee by doing that, if I multiply these, that I have something that is a product of these two. So x minus 4 and 3 are definitely both factors of 3x minus 12. But instead of writing it as 3x minus 12, I'm just going to write it as 3 times x minus 4. That's the same thing. And what that's going to do is allow us to cancel if the opportunity arises. All right, so I'm going to multiply this term over here times 3 times x minus 4 And I have to multiply this thing over here by 3 times x minus 4. So we are assuming something is going to cancel here, and it does. X minus 4 cancels with x minus 4. 3 cancels with 3. And now we don't have fractions anymore. That's kind of the goal here. 2x minus 3 equals 2 times x minus 4. So to finish that, I'll get 6x minus 9 equals 2x minus 8. I'll bring my 2x over to the left-hand side. I'll bring my negative 9 over to this side. Now I have 4x equals 1. X equals 1/4. So one thing that I would note here is to leave the common denominator as factored as possible. And if writing that doesn't necessarily mean anything to you, you could put, for example, like what we just did in this last one, 3 times x minus 4. Do not do this, because then it's going to be harder to cancel the different components with the denominators, like what we have here. Like if this looks like 3x minus 12, you're just going to have to break it apart again, so don't do that. All right, it's just a note, something to remind yourself of. Now, letter C is a little bit more intense just because one of our terms is a quadratic, that's this one here, and we should factor it first. So that's the key to letter C, is before you go looking for common denominators, factor everything. So I have x over x minus 4. I can't factor any of those. I've got 1 over x plus 3. Nothing I can do about those. I've got 28 over. I can do something about this x squared minus x minus 12. I cannot use the GCF method, so that's off the table. So now I'm going to try double bubble. And I'm looking for things that add to negative 1 and multiply to negative 12. So that's going to be negative 4 and positive 3, which works out really nicely because you'll notice our other denominators are those two things. So you can kind of liken this to the one above it, where we had x, 3, and 3x. Here we've got x minus 4, x plus 3, and the product of those two things, just like up here. So our common denominator is going to be this, because x minus 4 times x minus 3 is something that this is a factor of, this is a factor of, and this is a factor of. So that's what we'll multiply everything by. Everything. This gets in x minus 4 times x plus 3. This gets in x minus 4 times x plus 3. And this gets in x minus 4 times x plus 3. And now we can just start canceling things. So over here, I've got an x minus 4 divided by an x minus 4. That equals 1. Over here, I've got an x plus 3 divided by x plus 3. That equals 1. And over here, I can cancel two things, and I'll just be left with a 28 over there. So I have x times x plus 3 minus x minus 4. Don't forget to put that in parentheses because that's the whole quantity x minus 4 being subtracted, equals 28. Now I'm solving. If you're confused about that, that's because I distributed that negative. All right, I'm going to end up with a quadratic here, which means I want this side to equal 0. So let's get everything over to the other side. So I have x squared plus 2x from combining these like terms minus 24 equals 0. I'm going to have to double bubble this because I cannot use the GCF method. So x equals negative 6 and positive 4. And remember, if that did not double bubble, you'd be able to solve this using either the completing the square method or the quadratic formula as well. So the key to that example is really in the beginning of it, where we had to make sure we factored x squared minus x minus 12. So see, the key here is just factor everything. first. All right, I know this is a long video, but it should be enough to get you through the notes for the weekend, and then we can just start practicing this on Monday. So have a good weekend, you guys, and I'll see you Monday.